Yeah, what actually happened was that I had recorded this whole session, uh, yeah, a few days ago, and then I noticed that there was no sound. So I don't know what happened to the sound when I recorded that. So we'll try one more time to go through flash calculation, which is one of the most fundamental called calculations, very heavily used in the petroleum engineering processing space, etc. And it's nice to for everybody to at least go through that once. And actually, the next lesson would be to do an exercise where you actually are doing a so-called flash calculation in Excel. For that calculation, we're going to use the so-called standing K values, and K values was one of the earlier topics that we covered, and that's also why it's very good to go through flash calculations as a follow-up item to K values, or these equilibrium ratios. Good. So what we'll do now is just to simply go through to what is a flash calculation, and then we'll go through all the math. And a small warning there is that this is probably the lesson with the most derivations and equations, etc. in the particular course. So I guess if you don't like or if you think that is unnecessary, I guess this particular lesson is optional, but for those of you who would like to use this course as kind of like a stepping stone towards more advanced PVT topics, I really recommend you to at least do this once if you haven't done it many times already. I think we probably covered this particular topic 3 or 4 times in different courses actually in university. Good stuff. So a flash calculation, what is it? So let's just for now think about it as a black box. Something goes in and something goes out. And we can start with the things that go in. And what goes in is, first of all, this total fluid composition that we see here. The fluid composition is then provided together with a estimate of the so-called K values. K values is what we went through in the last section, so we need an initial guess for that. And as I said in that exercise that we're going to do, we're going to essentially assume that the standing K values are the correct ones. And then we also need a set of pressure and temperature. So we need the conditions at where we're going to do the flash calculation. So we have a total fluid composition and we have the pressure and temperature. And as we talked about earlier, what is PVT properties? One of the first things we mentioned, PVT properties, it is a function of pressure, temperature, and composition. And then we remember that we could simplify this composition with GOR and all these things. But it's all again back to this very fundamental understanding of what PVT is and what it is a function of. So out from this flash calculation, we get a few different outputs. First of all, we'll determine whether or not at that pressure and temperature whether we are at single phase conditions or if this is actually or this total composition is partitioning into a liquid and a vapor phase. So this is what we call sometimes VLE, call it VLE properties. So vapor, liquid, equilibrium. So this is for equilibrium. And so we do a vapor-liquid equilibrium calculation. That's what a flash calculation is. We get to know whether or not, first of all, we need to understand, is it a single phase or is it two phases? So is it a gas only, oil only, or both of the phases? Then we get, if it's two phases, then we get the amount of each phase in terms of moles. Okay, so we get the moles of each phase. And in addition, we get the composition of each phase. So the vapor and liquid compositions. Okay. So if and when we know the moles, we know that we can convert the moles, is something we can convert to mass, but to do that we need to know the molecular weights. And to convert from mass to volume, we need to know the densities, or the specific gravities. So these are also additional information that at least to create PVT, I guess tables, etc. that you need to know as well. But for the flash calculation isolated, these are the properties, and this is the output that you get. So the procedure or the flash calculation procedure is many times referred to as the so-called Rachford-Rice method, and in general, if I get this slide to work here, yeah, so a lot of equations on this slide, so yeah, we'll see. The first thing we need to do is to write up the so-called mole balance, and which essentially just says that how much we produce. For example, is how much we produce in the reservoir, and we bring it to surface. The total number of moles that we produce in the reservoir has to be equal to the total amount of moles that we produce at surface. So that's very simple. This is mole balance. And our good friend PowerPoint is not being a friend right here, but okay. So this is what we call a mole balance. And we can I guess define the